So for today's lesson, you're going to notice that a lot of the things we talk about today are going to be very similar to the things that we talked about when we did addition properties. Anybody nod your head if you remember addition properties. So we talked about the commutative property, the associative property, and the identity property. So, wait, did we talk about the identity property? Yeah. Okay, good. So today we're going to talk about those things plus one called the zero property. So, I know you did. So I'm glad. I hope that you remember it too. This time we're not. That's not one of the ones. We're doing associative, commutative, and identity again.
And zero.
I'm going to mention zero as well because we do talk about the zero property. All right. So let's go to the next slide where we talk about our essential question. Maybe use the other. Can you use the other part of the faucet? That way you can sit down. Thank you. So how is multiplying and dividing decimals similar to multiplying and dividing whole numbers? It is the same. We've talked about that. It's just like when you multiply or divide whole numbers. The difference is we have to add the decimal point to make sure we know where the decimal point goes in our answer. So like yesterday's lesson, we multiplied with powers of 10, where we would count the zeros on the number that we were multiplying by, and that was how many places we scooted the decimal point. Now that's really similar to when you multiply with whole numbers and you just add some zeros to the end of the other number when you multiply it. So hopefully you saw a similarity between what we did yesterday and what you did when we worked with whole numbers at the beginning of the year. You'll see that again in a few minutes. So here's your problem of the day. A book is open to two consecutive pages whose product is 1,806. What is the sum of the two page numbers? So before we can start to answer this question, we have to know what all of these words mean. So two consecutive pages. Does anybody have an idea what that would mean? Ava. They what? Continuous. I'll add to that. She says continuous. It means that they're in order. So they're continuous, like meaning one and then the other right after it. So would 5 and 12 be consecutive pages? No. Would 5 and 6 be consecutive pages? Yes. So you are thinking of two consecutive numbers who, when the sum, that means when you add them together, is going to equal 1,806. So guess and check would be a method to work out this problem. You would need to start with a couple of numbers. Now, are the numbers like 5 and 6 going to be numbers that you would start with? You're trying to get to 1,806. So you're going to need to start with some pretty big numbers. So think of a couple of numbers, try it out, see what happens, and then adjust your guess. Okay, so take a couple of minutes. You can use your whiteboard or you can use your notes if you have some space in your notes. All right, so you'll have time to work on this one after since we didn't get to figure it out. I'm going to come back to it. I'm not going to give you the answer though. So we're going to come back to it in a little bit. For your notes, Chapter 6, Lesson 8 is called Multiplication Properties. Just like I told you at the beginning of this lesson, that's an O. The addition properties and the multiplication properties are very similar to each other. So once I start telling, and it doesn't matter if we're talking about decimals or if we're talking about whole numbers, the properties are the properties, that's it. So here's the first one I need you to write down into your notes. Write this down. So here's my example. Grouped. We did. The lesson that we did though was about addition properties. So that's the difference. So today we're talking about multiplication. So multiplication and division, remember, are inverse of each other. The word inverse means opposite. So when we do multiplication and addition, it's like you can find a multiplication answer by repeated addition, right? So you could add something up a whole bunch of times and get the answer to it, to the question, to a multiplication problem, really, if you wanted to do that. So they have a lot of things in common with each other. So these properties is just one of those things. So just like addition, when you're multiplying numbers, you can multiply them in different groups, like you can multiply different groups together. Notice on this example, the numbers didn't change order. So we have 3, 5, and 2 on one side of the equal sign, and we have 3, 5, and 2 on the other side of the equal sign. And then you can see where in the first one over here, we grouped 3 times 5 first, and over here we grouped up the 5 times 2 first. So that would just mean that whatever you put in parentheses is what you solve first. No matter which one you do, you're going to get the same answer. So if I multiply 3 times 5, I get 15. 15 times 2 is 30. On this side of the equal sign, 5 times 2 is 10, and I would multiply that by 3, which I still get 30. So what this is saying is no matter how you want to group the numbers, you will get the same answer in the end, no matter if you group them differently than your neighbor does. So this comes in handy when we're working with decimals, because sometimes you can multiply certain things together that you can do in your head. Then you take all of them together to multiply. So let's say you're multiplying a decimal, you have a decimal and 2 whole numbers that you're multiplying. You may choose to group them differently by multiplying the 2 whole numbers first and then multiplying that answer by the decimal. So you're really only having to work one thing out, because you can probably do the whole numbers in your head, right? So then you're not having to do quite as much work. So that's where these properties will help you in the upcoming lessons. So associative, the way the factors are grouped do not change the product. So now we're going to write about commutative, which is the second one. Now commutative means the order that the factors are multiplied doesn't change the product. Just be careful with it. So this means if you want to change around the order of the number, so in the associative property is where we have the parentheses. So on that one, because what you're going to do in the lesson today is you're probably going to, most of them are going to be already done for you, and all you have to do is say what the property is that's used to solve that one. And sometimes you can use multiple properties. So sometimes they might choose to move the numbers around first and then group them, so they'd be using both the commutative and the associative property. So sometimes you can use more than one property to solve the problem. Most of the time you're going to do this without even thinking. If you have 3 numbers, like let's see. Sometimes you do the associative maybe without even putting numbers, like putting parentheses around it. You just figure the ones you're going to group first. So maybe you have something like this. These numbers, and of course we're going to be working with decimals today, but let's say that you had these as whole numbers, and if I were going to work this out, I may want to move some things around and make it 6 times 2 first, so I can do 12, and then multiply that answer by 18, and that may be easier for you. So sometimes you can do, you can move numbers around so that you can do basic facts in your head, so things that you can move around more easily. So I already know that 6 times 2 is 12, so then on the side maybe I have to do my math problem like this, and I'm only multiplying once that wasn't in my head, okay, and then the other one you're doing in your head. So this was a more simple example. If the numbers were bigger, like if you had a number in the hundreds and then you had like a 2 and a 5, you're probably going to want to multiply the 2 and the 5 first, and then multiply it by the 152 or whatever it is, right? So changing the order of the numbers helps you to do, you're trying to move the numbers around in such a way that you could do the multiplication, some of the multiplication in your head at least. If not all of it, at least some of it. Okay, the last one is the identity property. Oops. This thing's doing some weird things today. Okay, so the identity property says that the products of any factor and 1 equals the factor. Now, if you recall, when we did addition properties, this one was a little bit different because it was when you add a 0, it was when you add a 0 with any other number, you're always going to end up with whatever the number was that you started with, right? We talked about that. So this is different because when you multiply, you would have to multiply the number by 1 in order to get what you started with. So that's what this is saying. So the identity property means that when you multiply any number and 1, you end up with whatever the number was that you started with. So for example, 547 times 1 gives you 547. And of course, the same rules apply when we talk about decimals. So when if I gave you 76 thousandths times 1, you would get 76 thousandths as your answer. Okay, no matter what it is, if you multiply it by 1, you end up with whatever you started with. Now there's one more property, I don't have it in my notes, but just in case it comes up, it's called the 0 property. Anybody know what that one does? Nolan, what do you think?
I'm pretty sure it was this one. I'm not sure. I might be getting my old lessons mixed up.
Okay.
But
let's
you do any number with a 0 at the end, multiplied by another number.
Oh, no, it doesn't have to do with the zeros at the end.
Okay, no.
Karnpreet, what do you think?
Anything times 0 is 0?
Yes. So if you come across, you're saying any number that has a 0 at the end of it. That's,
yeah, because I was
well, it doesn't have to do with,
I'm getting really confused.
so here it is, watch. The identity property in addition involves a 0, because when you add a number and 0, you get whatever number you started with. The identity property in multiplication is with a 1 instead of a 0. So we have actually one more rule. Any factor and 0 will equal 0 when multiplied. I didn't add that in. So that means anytime you multiply something by 0, you always get 0. So don't you remember that when you learned your basic facts, your zeros are super easy, right? Because no matter what you multiply by 0, you're going to get a 0 as your answer. So the same thing goes for decimals too. When we talk about decimals, this property still exists then. So anytime you're multiplying something by a 0, you get a 0. Sometimes some people get a little bit confused, like what Nolan was saying too, like between identity property, because the identity property is two different things depending on if you're talking about addition or if you're talking about multiplication. So like when we take our math proficiency at the end of the trimester and you have questions from the whole trimester and they ask about the identity property, make sure that you know if you're talking about identity property of multiplication or the identity property of addition, because those are going to be different things. Hamza. It may be on there. That's why I wanted to make sure you knew about it. But we all knew that anything multiplied by 0 gives you 0. I just wanted to make sure we wrote it in just in case you see it. Angelina. Right, so that's the identity property when you talk about addition, but when you talk about multiplication, you get a 0. You don't get whatever number you started with. Karnpreet.
In the test, it might show this because they might put something, they might put zero property, but we might have not learned that. That's why you have to make 10.
Yes, right. I just want to make sure that you know about it because it is one of the properties. So here was my example that I put in there. 6 and 2/10 times 0 equals 0. There's a good example. So anytime you have something multiplied by 0, it's going to give you 0 as your answer. Okay, let's look over at your math page and see if we can use some of what we've learned. Don't put your notes away because you're going to use your notes. Example number 1 says, a coach has 16 players. I'll wait till you grab that paper so you can hear the example. Everybody have their math paper?
I still
We haven't. All you've done so far is take some notes. We haven't gotten that far yet. All you did was take notes. Keep your notes in front of you because we're going to go back and you're going to use your notes to help you remember what to put on this paper. So example number 1 says, a coach had 16 players in each of 2 groups. Each player scored 5 goals. Find the total number of goals scored. So with a question like this, it's a word problem and you have to figure out what numbers you're multiplying and if you're multiplying or if you're supposed to add or if you're supposed to subtract. That's one of the main questions that people ask me, like when we get started on the homework. Am I supposed to multiply here or am I supposed to add here? Like they're not sure. So if a coach has 16 players in each of 2 groups, that's where they came up with 16 times 2 here. This is the group. Each of those players scored 5 goals. So we'd have to figure out how many total players there were by multiplying 16 times 2 and then multiplying that number times 5 because every player scored 5 goals. So here is the part that I was trying to explain to you earlier. You can easily multiply 2 times 5. I think most of us can probably multiply 16 times 2 also, and it would be okay. But if you did that, you're going to get a number like 32, and then you're going to have to multiply that by 5. Do you see the difference? So if I already, even if I know in my head that 16 times 2 is 32, I'm still going to have to figure out what is 32 times 5. So there's a better way to group these numbers so that I don't have to do any work on my paper. So the better way to group the numbers would be to switch the numbers around, switch the numbers around so that you can multiply 2 times 5 first. So instead of grouping here, they switched and they grouped over here because 2 times 5 is 10. And it's super easy to multiply powers of 10. So 10 times 16 is going to be 160. You just add a 0 to the end. So the total number scored is 160. Now you could find the answer. You could find the answer by not switching the groups. But if you did that, you would have to do 32 times 5 up here and do this multiplication and get 160. So see how it's so much easier to regroup the way you multiplied so that then you could do it all in your head. So because we didn't change the order of these numbers, we still have 16, 2, and 5, 16, 2, and 5. That's why we've used the associative property. We didn't have to use the commutative property here because we actually didn't scoot any of them. We didn't mix any of the numbers up or anything. We didn't move anything around. All we did was regroup. So instead of grouping 16 times 2 first, we chose to group 2 times 5 first. That was all. Then we multiplied. All right, let's look at example number 2. Find the unknown in the equation. So you're going to see some like this on your assignment today as well. So there's the little gray box, and you have to decide what number is going to go into the box. And they have to be equal. So one side of the equation has to be equal to the other side of the equation. So if you have 35 and 5/10 times something, and it's going to be equal to 17 times 35 and 5/10, Angelina, what number has to be in the box? 17. Did it actually ask us to find the answer?
No.
We didn't really have to. All it asked us was one side of the equation has to be equal to the other. And because this side had a 17, this side over here has to also have a 17. They were in a different order though, right? So that's why we used commutative property, because they were in a different order. So you had the decimal first and then the 17, and then on the second side you had the whole number first and then the decimal. So that's why we use the commutative property. Yes, Nolan?
Miss Mateo, on that, it looks like a 7 when you circled it like that.
Well, on your paper, you should be able to see that it's a 17. There we go.
And
Okay, any
also-
questions so far?
And also, what if you, like, say you, if it tells you to, say all the properties that you use, do you write them? Because it says, like...
Yes,
if it
they'll
says,
probably
like,
give you some
identify
lines.
the properties you used.
Right.
You write them?
Yes. Anytime it says to identify the properties, it means that they want you to write the properties that were used. Okay, example number 3, last one. Find the unknown in this equation. 17 times something equals 17. What would it be, Concrete? 1. Because anytime you multiply something by itself, you get whatever number you started with. Wait, anytime you multiply 1 by a whole number, or any other number actually, you get whatever number you started with. That was the identity property. What if I gave you one that looked like this? Then what number would go in the blank? Vicky? 0. And what property is used to solve that one? Vicky, what property? The identity one goes with the 1. The 0 property. So 0 would go in the box, and that's the 0 property that's used. Okay, so I'm going to look through first.
That's not the 0 property.
Hold on. Hold on, stop. You might have missed that down here underneath. Hold on, I know. Maybe you missed this part. I wrote an extra problem down here that looked like this. And then I asked Vicky to solve for that problem. That's where we got, I didn't want you to get confused. Okay, so look in your, look further into your assignment, because I want to just show you what some of the directions are going to look like. So the first set of directions say to draw lines to match the multiplication property that was used. So okay, so on this one all you're doing is drawing some lines to which property you would like, that you think was used. On these ones, use properties of multiplication to find each product mentally. Show your steps. Ooh, this part's important. Show your steps. And identify the property that you used. So here's how you would show your steps, because yesterday we had a problem with this part. So here's how you would show your steps. I think that when I look at number 4, I think it's going to be easier to multiply 2 times 50, because that's going to easily give me 100, right? So I'm going to change the grouping, and I'm going to make it 2 times 50. So far I've used the associative property, and then I'm going to multiply. It's going to look like this. So I didn't change the order of the numbers, did I? The order of the numbers stayed the same. I just changed the way I grouped it. So just like I told you earlier, if you have 2 whole numbers there, it's always going to be easier for you to multiply the 2 whole numbers first, and then multiply that number by the decimal, because usually you're going to see 3 numbers in these. So if you can multiply the 2 whole numbers first, that's going to give you an easier way to multiply all in your head. So now I have 100, because 2 times 50 is 100. Let me rewrite that. 2 times 50 is 100, and now I'm multiplying 5 1/10 by 100. And remember how yesterday we learned that when you multiply by a power of 10, I'm going to scoot that decimal over twice. 1, 2. So then my answer is 510. And the property I used was the associative property. This thing keeps messing up. So you have to show your work, and you have to identify the property. So my answer would be 510, but if you just put this, you can't get credit, because you have to show what you did. Then you have to list what properties that you used. Look at this number right here, number 5. Here's what I have. 4 times 2 5/10 times 6. I'm going to multiply the whole numbers together first, right? So I'm going to change the order of these numbers. What is it called when I change the order of the numbers? Concrete. Commutative. Number 4, I didn't change the order of the numbers, and that's why that one was associative. Now it's commutative, so I'm going to be changing the order of the numbers. So I'm going to make it 4 times 6 first. Then I'll multiply it by 2 and 5/10. That way I can get 24 here, and then I'll multiply that by 2 and 5/10. So maybe on the side, you have a little problem over here to try to figure it out. But if you wouldn't have changed the order, you would multiply 2 and 5/10 times 6, which is going to give you a decimal answer, and then you'd have to multiply that a second time by 4. Do you see how by moving the numbers around, I was able to do 4 times 6 in my head? So at least you still had 2 multiplication problems to do, but at least one of them was whole numbers that I could do easily in my head. That's the point. So on this one, actually, I used 2 properties. I used commutative because I moved the numbers around, and then I used associative because I grouped them differently. See that? What if I'm doing number 6? What would be what I would want to multiply together first on number 6? Jameson, what do you think? On number 6. You looked at number 5. What do you think? 2 times 500 first. I haven't changed the order of the numbers. I'm just going to change the way they're grouped. And I'm going to multiply 500 times 2 and get 1,000. I'm going to multiply that by 9 and 8/10. And now that looks like a problem I just did yesterday. See? So now I've used the associative property on number 6. Because I didn't change the order of the numbers, all I did was change the grouping, which one I was going to multiply first. So, one more thing before I want you to start. The whole point of this is to learn how to cut down on how much work you're going to do. So I know that all of you would rather have a shortcut and have to do less work, right, and be able to do the majority of it in your head, because I know you like that. So that's what this is about. It's about seeing what 2 numbers can I multiply together in my head so that I can then just do one math problem on paper. So you're trying to do as much as you can in your head. Maybe you can do all of it in your head. Like this one, now all I have to do is take 9 and 8/10 and scoot it 3 times.
Yep.
And there's my answer. See, so I didn't really have to do any math on that one. But if I chose to not move anything around, here's what I would have had to do. Now that's a long math problem, isn't it? Look up here and see. Isn't that going to be a long math problem? To try to figure out 500 times 9 and 8/10. And then the problem's still not over, because once I get that answer, I have to multiply it by 2, because that's what's left of the problem. That was 2 math problems that I had to do. But if I would take the advice of Ashley, and I take 500 times 2 first, instead, I get 1,000, and I multiply that by 9 and 8/10.
So your answer is
9,800, because I had to move it 3 times. So I had to have 2 zeros. So do you see the difference? Look, I finished that problem already. And all that I had to do was change the order of how I multiplied the numbers. I multiplied them in a different grouping. Nod your head if you see the value of this. Okay. Because it's not just about doing more work, it's actually about doing less work. It's trying to figure out how I can multiply these numbers so I don't have to do so much work. Okay, so try it out. You can work with your neighbor if you need to. Make sure you read the directions, because sometimes the directions will change, but they do want you to show which properties were used, and so you do need to list out which properties. So tomorrow when we grade, you're going to get points for if you get the answer right, but you're also going to get points for listing out the properties that you used. Okay?